In the previous video, we set everything up to begin working with the client side. At this point, all of our dependencies are installed and all our API request wrappers are auto-generated. If they are not auto-generated, then you probably could do them manually. But at this point, we assume they are compiling smoothly. Now, we can finally focus on writing code of a reactive interface. As you are aware from the previous part, Leptos is a new and exciting framework, and contact form example with the reactive selection of calendar slots will be ideal for learning typical patterns of its use. It also allows us to address most of the common challenges that comes with Leptos. In general, Leptos successfully mimics React.js style of programming, but the internals are absolutely different due to nature of strict type system, the language itself, and so-called fine-grained reactivity. We begin developing the client side by planning the routes our application will use. In this area, Rust is a real game changer for enhancing the robustness of the client side. It allows us to declare all routes as an enum structure with parameters, providing a compile time guarantee that no broken links will occur. Here's how it works. We should always use the route enum with the conversion to a string definition. We'll name this function into route, and conveniently, AI autocompletion quickly helps with that. The second function, which converts the routes in the declaration section, can be named into static, and it uses declaration in the format of Leptos router. The top-level component function can be called layout, and it will be a wrapper for our routes declaration. Screens are the components that are mounted when routes are changed. Autocompletion is outdated. There is no more scope parameter. Here comes our default route, a home screen. Let it be just a dummy example of a single link that looks like a button in the center of the screen. That link will lead a user to the book screen, where a user can leave a message and book a calendar slot on a certain date. Book screen is the one that will always have date parameter in the URL query, and we are dealing now with the first challenge that would not be a big deal in React, for example. In React, all the pieces of components are always dynamic and are re-rendered every time with an internal mechanism of optimizations. But here in Leptos, every scalar parameter that is included in the view will be rendered only at the time of component mounting. And if you need dynamic parts of the component, you must use it only from the closure. So the first thing we are doing is introducing closure function to get date in a proper format and handle all possible error cases. Similar to that, there could be functions to get the previous and the succeeding dates. After getting functions are defined, it's time for the simplest HTML and first visual checks. Command line command trunk serve will start our server on port 8080. And we see nothing so far. It means we need to have main rs file with mounting procedure. Now we have layout, it seems to be mounted, but there are still errors. We are not getting into any route, and here is why. The correct hierarchy is router, then routes, then individual route. Well, first step is successful. We have links displayed and the navigation between them works. So we can improve the look of the booking screen. We can have back button nicer, and at the top we can have links to move to previous and to succeeding date while displaying current date with the weekday in the center. These links seem to work now. Now, when we are done with the book screen component, it is time to develop a chart component. It should be updated every time the date changes in the route parameters, so we need to introduce date as corresponding read-only signal of naive date. The first thing we care when starting with chart component is setting the model for its data exchange. To emulate internal state of the component, we initialize separate read-write signals: name, email, message, hour, duration. And here will be one more subcomponent for our slot selection. The second thing is the definition of where that data will be transferred and in what form it will be conducted. In the contact form, we will be submitting all that data to our submit endpoint on the server in the form of the contact form request, so it makes sense to accumulate it in a local read-write signal. But as you can see in our selector component above, the result of our selection, our RW, will be a read-write signal that will notify back its parent, and this is more typical pattern that you'll see. So here comes the closure to keep that contact form request up to date anytime we have values changed in the internal state. And this is the pattern for it. Date comparison and setting slots will take some significant space, so we will add a few functions to the protocol, as such comparisons and basically setters are easy to debug in plain Rust outside of heavily nested structure, especially with macroses. Okay, we have data exchange planned, so time to drop some HTML. So let there be a form. With a few text inputs in the first place, and with the dumbest way to show our internals of what the request will be. Two inputs and one text area like this. Let's test them. Let's have a better styling now for the submission button. It's time to introduce some conditions. A good example would be to avoid calendar slots booking on weekends or in the past. What is important and unusual for former React developer, this is dynamic information, so that has to be wrapped into closure. And once it is in the closure, we can use a component called show storing this condition. I'm clicking back and next, and the condition works. Continuing with challenges, let's write our hours selection component where we will face the necessity of having the loop over all the hours. As the trick here will be to overcome Rust borrow checker, it will be done with the special for component. Auto suggestion here is a mess, so let's clean it a bit. Each child must be a button that is responsible for selecting the given hour. And if the hour is already selected, it should receive different styling. The last step is the actual HTML of the button. Looks good for me. Okay, we saw the main pattern of parent-child communication via signals. Now, let's see the example of the second main pattern of working with the global state. And I just cheated again. I copy-pasted the existing component of toast notifications as example of state provisioning. Here, there are two important lines in it. This is exactly how it provides its internal state to all child components with provide context function. You can actually find very similar component on crates, and its implementation is not that relevant. But what is important to understand is such component has to be on the top level on the router or above. We wanted to have toast component to be a visual representation of reaction to result of sending anything to the server, and this is how it can be done. As the submission using our API client is asynchronous, there are very little patterns Rust compiler will allow you to do this. One of them is called actions, and this is what we are defining now. It consumes a handler that returns a synchronous function, and that function calls out API request function defined in the previous video. Once result of the API response is received, we will update the state of our toast provider by pushing either success or error, depending on the results. In case of success, we should clean the fields. Once created, such action should be dispatched. Checking it, there is no email server connection, but the second attempt shows the slot is already busy. Okay, we need to define proper usage for the API methods and response type. Busy slots list can be downloaded by calling create resource, and it has a special filter for the list. On every submission, we need to refetch that data. Now, the only consumer of the data should be our selector component. So let's call it only when such data is loaded and use loaded busy slots as a parameter to the component. All errors should be handled, and I just copy-pasted screen error function component to display error screen wide. Now data about busy slots is actually in the component, and after all other cases of its absence were handled, let's think about the implementation. What we actually need here is to treat selected and blocked hours in a different way. If the hour is busy, there should be no button. We should display div instead. Let's check the form. Email server wasn't configured, but the slot became busy, so it worked. We are good to deploy. Let's stop trunk server and call trunk build. Nginx configuration should be set for serving static files with a fallback to index.html. In Dockerfile, we will just serve our distribution folder. Now, building the Docker and deploying Terraform plan. Well, doesn't seem to work. Okay, that was just an extra character in Nginx configuration. It's good now. Trying it again. As you remember, email server wasn't configured there. This is why you still see red alert, but the slot became busy, so we can consider it working. So basically this is it. In 8 videos and roughly speaking 2 hours, we've managed to watch the whole cycle of web application delivery, including infrastructure configuration for website publishing and the general way of thinking during server-side API creation and modern, robust, reactive clients. Hope that was useful for you and you found something new for yourself during our journey. If you want to see more coding sessions like this, please like, subscribe to the channel, share this playlist, and of course, leave your feedback in the comment section below.